Namaskar, I'm Harpreet Kaur and I welcome you all to our live and interactive session on virtual labs. You are watching us live right now on PM eVidya channels 6 to 12 and also on our YouTube handle NCERT Official. This session is specially meant for our students of grade 10 where the subject that we are taking up is science. We are going to learn about one interesting topic from your textbook. This is demonstration of simulation on household circuits. So we will be having a simulation on this topic. If you have questions, please feel free to get in touch with us. Our phone number is 8800440559. We also have a dedicated email ID for you, that is diksha.training at CIET.nic.in. And on our YouTube handle NCERT Official, you can send us your questions, suggestions and your feedback. To make our sessions more inclusive, we are joined by our Indian Sign Language interpreter, Miss Anushka Sharma. Namaskar, we welcome you to the session. Now, before I introduce you all to my guests for the session, it is important for me to tell you something about virtual labs. We have been doing these sessions for quite some time now, and you must know what virtual labs are in case you are interested in learning any topic in a blended mode. Yes, NEP 2020 talks about blended mode of learning, which is a beautiful combination of offline and online resources. So in virtual labs, we have this application which requires a stable internet connection and an IoT device. And on this application, you can not only study the material that is there in your NCERT textbooks, but you can also perform the experiments virtually, and we call them simulations. It's not just about learning the concepts of sciences, but be it mathematics, social sciences, or even languages, you can learn anything across the disciplines through this medium called virtual labs. It's very cost effective, available to all, and it has content for our diverse learners as per their unique learning styles. Now, there are many questions that come to our mind. Do we need to go to real physical laboratories, or virtual labs are enough? Well, this question can be answered by our expert. Whether we need a teacher or self-instructional material present in the virtual lab is good enough. So these are the questions that I have on my mind, and I'll be asking them to my guest for the session. So please join me in welcoming Dr. Uma D. Sharma, Ma'am is Consultant Academic from CIET, NCERT, New Delhi. Ma'am, namaskar and very warm welcome to you.
Namaskar and thank you.
Ma'am, every time when we talk about virtual labs, lots of questions, crop up, whether we need teachers or not, whether we need real physical laboratories or not. So before I actually ask you, what are we going to learn today? I want to ask you, is it possible that we can learn everything through virtual labs and we do not require teachers or physical laboratories?
No, that's not possible, because both are equally important in today's world. Teacher intervention is also as important as a virtual lab, because both are like complement each other.
Okay. And ma'am, now let's try to find out what we're going to learn today. This topic about household circuits.
Yes.
What we have in the topic?
This is a class 10th topic, household circuits, in which we understand how the electricity which we get in our homes, so how it distribute, and what are the main, from where the electricity is generated, and how the distribution is possible in our households.
Right. Ma'am, I remember, listening to terms like AC, DC, alternate current, direct current.
Yes, exactly.
But because I'm not a science student and I want to learn this concept through virtual labs. So I want to ask you, how can we learn? Because virtual labs are meant for all. So please tell us how this topic can be understood by a learner like me who doesn't have science background, by anybody who is a member of general public, homemaker, or just is curious to know about different topics. So please take us to the virtual labs and tell us how we can go about the topic.
Sure. So we can access this topic directly through virtual labs vertical, and it is a class, as it is a class 10th topic, so we can go directly to the class 10th topic, and there you will find this household circuits.
Do we need to register, ma'am?
Yes, once we need a one-time registration is required in Diksha platform, and once it is done, you can directly access through it. So no problem with that.
And ma'am, we can open this application on a desktop, laptop, mobile phone, everywhere.
Everywhere. Okay. It is compatible to mobile phone as well as a desktop.
All right.
So you can go through it, and simply I just show it to you, like Diksha from this virtual labs. One vertical is there, and here directly you can go to the class 10th, grade 10th, and English medium, science is there. And once you click it, you will get a entire TOC over here on the right hand side, where entire experiments are available. I have already opened this experiment for you.
TOC means table of content.
Table of content is there, and all the experiments are arranged over here one by one, and there itself it's a household circuit is there. So I have already opened. So you can see this household circuits, and this objective of this lab is to identify the components of the typical domestic electrical circuits and analyze the function of each of it safety devices, because it is very important for a student to know, to understand how the current flows through the circuits and what are the key components of the household circuits. So here we go now.
And ma'am, circuits appear to be very complex as such, but I think through virtual labs we can simplify this topic.
Sure. So before going further, I just wanted to show you the theory part, which is available in the same lab, and here this theory is in the form of video. So the student will understand the entire process of how electricity is generated and how it is, like from the main pole, from the main you can say the area where the current is generated. From there, the main pole, the current passes through our households in a form of 3 wires. So it is first the current is passing through the live wire, which is called phase, live wire phase, and then from the neutral wire it goes out from our houses, and we are just accessing this electric current. It is not like it is permanent there. So it is just, you can see this overhead poles are there from this pole, and the one distribution box is there, and this red color is live wire, and this black wire is a neutral wire, and then it passed on to the next household. So this is a basic thing, and from here this is a barrier between the entire circuit of an entire electrical component which are present in the house, and like from here it distribute to each and every appliances. So we understand how it happens. So normally all the appliances in the house is connected in parallel. We are like because what is the advantage? Because parallel connection. Let me first of all explain this meter board as it is. The image is here. See, this is the distribution box of this which we have seen at our homes also. Sometimes what happens, due to overloading or due to high current influx of a high current, the MCBs goes down, and the entire circuit of one room is stopped. So what exactly happens over there? Because and in other rooms the current is going on. That's why. So this implies that all the circuits all the appliances are connected in a parallel mode, in a parallel connection, and room wise it is distributed. So here you can see this neutral wire is there, live wire is there, earth wire is there, and this from the live wire the 220 voltage is coming, and from the neutral wire it is a 0 voltage. It does not have any potential. It is just here to complete the circuit. And earth wire, I will later on I will tell you the importance of the earth wire also. Second thing is electricity meter. This from where our how much electricity how the units we have taken, and the unit of it is kilowatt hour. So normally the commercial unit of the energy consumption which we used to measure from here, which is in kilowatt hour. And then from here now it is distributed to the distribution box here. And here this is the electricity board fuse is also there. The fuse also, like MCBs are the mini circuit breaker is there, miniature circuit breaker. So once why MCB is down, because the fuse inside it got melted or overheated due to the overloading. So it overheating. So it got disconnect the entire current supply and protecting all the appliances. So this is the role of the electric fuse, because it has a very low melting point. Normally we require 5 ampere of current and 15 ampere of current. So accordingly fuse wire is attached to this MCB terminal, and if the current is excess more than this 5 ampere or 15 ampere, accordingly it get melted down and protect the entire circuit.
Okay, so that's why it has a low melting point, because as soon as the load increases, it melts and prevents the short circuit, as we call
short circuit. Now let me, I will show you this thing. See the distribution box and how the current, how this distributed to different switches.
Okay.
Okay, you can see this, and each switches have 3 terminals, 3 points are there. One is for, this green is for earth wire, this one red is for live wire, and this black is for the neutral, and how they are connected. Now here you have seen 2 kinds of switches are there. At home also we see 2 kinds of switches. Okay, why is that? Because for heavy load appliances we require a 15 ampere of current. They will not get they will not operate in 5 ampere.
Yes.
And like fans are there, bulbs are there. For that we need a 5 ampere of current load. So accordingly these switches are there, and accordingly we have to divide the entire current in 2 parts.
Okay,
we have to divide it into 2 parts. One is 5 ampere of circuit and one is 15 ampere of circuit.
Right.
Okay, so this is a theory part.
And very interesting. It's explained through a very catchy video. I never knew what these 3 holes meant in a a switch.
Okay. And now why parallel connections are vital here, with this diagram I will explain it to you. Like see, in what happens when a series connection, 2 bulbs are connected end to end like this. Okay, and both have the same, both will have same current, positive, because high voltage is the live wire and low voltage is the neutral wire. It is connected like this. Now if the one bulb fuses, just imagine one fan is not operating, so it will like what will happen, the circuit will break up and the other appliances will also not operates. And in this case the voltage is also divided into 2 parts. So it will get a difficulty in operating the appliances also. But in the case of parallel connection, what will happen, the voltage is same for both the appliances. Like the bulbs are here, the just appliances. Suppose 2 fans, 2 or any 2 appliances are connected. So all the appliances can be connected in a parallel mode at the same time with the same voltage.
All right. And now what kind of connections or circuits do we have at our homes?
That is parallel only. That is parallel only, so that like our AC, our fridge, our microwave, each will get a 220 voltage of power supply at the same time. But we should avoid using all the heavy loads at the same time. Because like what happens if AC is there, you are operating AC also, geyser, microwave, geyser, all are taking 220 voltage, but the wire, because they are drawing the current of 15 ampere. So if it is more than its limit, overheating will take place. So that's why if AC is on, geyser is on, we have to distribute our time accordingly to avoid overheating. Let's proceed.
Yes, sure.
So this is simply all the theory part. Now let's simply, they have explained all the other things, like what will happen. The appliances will keep on working if it is in parallel connection. And last thing is, I just wanted to explain about the earthing. See, sometimes we have, when we are small, we have observed this thing. We got a current from the fridge surface. I think everyone has this kind of experience with that.
Especially during the rainy season.
Yes, during the rainy season. So what happens at that time, maybe the live wire, which conducts the high voltage, get touched with the metallic body of this surface. So in that case, the current, the current is like the leakage of current takes place to the metallic body. And in this case, if it is not a 3-pin plug, so you will get a severe electric shock in that case. So that's why this in this kind of like a toaster or a fridge,
or
we have a 3-pin.
In the iron also.
They have a 3-pin, because what will happen if some kind of this kind of leakage current takes place, so the earthing wire is directly connected to the earth, and it gives a safe passage to the low resistance passage to the excess current, and that excess current directly pass to the ground surface. So you will not get a severe shock, just minor like vibration kind of thing you will experience, but you will not get a 220 voltage of shock. So that is a like advantage of earthing, and we should like always buy those kinds of appliances which have this 3 pins earthing is there in which. Okay, now I think we will move to the simulation part now. So, this is a simulation, let us start it.
Sure. Now, here you are showing us the household circuit, household setting, and we will learn how the current is being passed. Okay.
I have already opened, but I am not finding it.
So, I am sure there are so many questions that are coming to your mind. You can definitely ask them. And ma'am, what about AC, DC? We also hear these terms, alternate current.
So, in house we are using alternating currents only, alternating currents, and when the from this battery, or we can say the inverter, the DC current is there.
Because where we need more power, continuous power.
That is AC current only.
AC current only, okay.
Both are continuous, AC and DC both are continuous, but DC is the direct current which has a 0 frequency, and AC has a 50 hertz of frequency.
All right.
Okay. Now, let us start with this simulation part. See, it is a kind of a activity kind of, in which some gamified version is also there. So, in kind of games, student can enjoy this entire setup. They understand the concept also.
Very nice.
And so, welcome to the household circuit lab is there. What is its mission? To get a room up and running. Okay. So, in this we can see one fridge is there, TV is there, all are like they are not connected, the switches boards are not connected. So, by this activity student will connect all these appliances correctly and just check whether they are okay or not.
Okay.
So, click on the first we click on the distribution box. So, they are just saying this is a distribution box and identify. Okay. So, click on the lamp first, we will click on the lamp. So, as we connected the lamp, so where should the lamp will be connected? It is a low power appliance.
Yes.
So, it should be across 5 ampere of a circuit. Yes. Then laptop.
Low power device?
Low power means it does not require high current.
High current. Okay.
They require a 220 voltage, but current requirement is only 5 ampere. If you connect it through a 15 ampere circuit, so maybe some circuit will, or it will be more current will pass through it. So, again the laptop will be also 5 ampere.
Damaged, yeah.
Next, AC is a high power, it is a AC in the rooms, it is a high power device.
Yes.
So, we will just connect it to 15 ampere.
Yeah.
5, let us try. So, here it is just let us try connecting the AC to the 5 ampere socket and see what will happen.
Okay.
To just see what will happen in that case. So, let us connect it, then what will happen? Here we will check the distribution, the overload has caused the other appliances on the same circuit to malfunction, because due to overloading the fuse will get melted up and MCB is down here. So, click on the distribution box and correct it. Okay, we have this, see MCB is down here. So, I have to correct it. Okay. Next, now I will do it correctly. I will just connect it with the 15 ampere and I understood, because what will happen, overloading, because with the 5 ampere already two sources are connected, and then again I have connected this thing. So, it draws more current than 5 ampere.
Yes.
So, that is why MCB is down. So, we have to connect it with the 15 ampere. Now great job, the AC is now on. Now, this demonstrates how heavy appliances needs to be connected to a 15 ampere sockets, while lighter ones runs on the 5 ampere circuits. So, all working together, and see all are working together in a parallel without affecting each other, because they have a separate connections. For 5 ampere they have a separate, parallelly they are connected, all 5 amperes are parallelly connected, all 15 amperes are connected to 5
they have different sockets.
Now, let us get a TV connected. Now, TV. Now, again TV we will connect to the 5 ampere. Next, the
fridge.
Earthing. Now, earthing is not there. Next, click on the click next to the open the faulty socket and fix the grounding. Here we can see in this case I have inside live, see here this is a faulty circuit, because here earthing is discontinued over here, it is broken. So, we have to fix this so that it will the earthing will not, it is getting some shock on the surface, metallic body of the TV. Okay. So, we will connect it, we will just make it correct over here.
We are making the circuit complete by connecting the earthing wire.
Now we have corrected it.
Okay.
And now next grounding is done. So, now it is grounding is done. So, some discrimination, some error is occurred over here. So, that is resolved now. Now let's get the fridge connected.
Yes.
In this case, fridge, again it is a heavy appliances. Now here you can see in the, if you see this diagram, see this is a parallel connection. All 15 amperes, they are parallelly connected to the main source. All 5 amperes are connected parallelly to the main source, and here you can see this, 2 MCBs are there. One MCB is for mini circuit breaker, miniature circuit breaker for 5 ampere current loop, and one is for 15 ampere circuit loop. So if some fault sometimes happens in the case of fridge or something, so in that case this MCB will get down. So accordingly we will have to check it. Now next is, the fridge is connected to the correct 15 ampere of socket, but the 15 ampere MCB has tripled for the safety. Here some error is there in the case of wiring.
Okay.
So let's investigate. Replace wire. We have replaced the wire because if the wire is broken or something, it is high chances of short circuit is there. Okay. So we have done it correctly. Yes. Now it is also working. So what we have learnt with this entire activity, we have completed the entire mission, household circuit mission. We named it household circuit mission. And what you have learnt, like the light appliances like 5 ampere sockets, okay, they uses 5 ampere sockets. Heavy appliances like AC and fridge uses 15 amperes of sockets. Appliances are connected in parallel, so they work independently.
Right.
Each will work independently. Now if this laptop is off, I am offing it, that means circuit is broken. Okay, I have closed the circuit, I have opened the circuit, we can say that, off it, but other appliances are keep on working.
Yes.
Now if lamp is fused, so it does not act like all, if they are connected in a series, all the appliances which are of 5 ampere, they will stop working.
Yeah.
So this is the reason, that is why they are connected in parallel. And MCBs protect circuits from overload and short circuits. They are miniature circuit breakers, which are called MCBs. And final point, proper earthing keeps the appliances safe to touch, because it gives a very low resistance path to the current, and the high current directly pass to the this ground, and and hence it is protected.
And it also protects many accidents which are caused due to electric currents.
Yes.
So it's a very interesting, because I think in a very gaming manner, you can understand this entire setting, what kind of sockets are being used and how the household circuit actually works. Now ma'am, that we have understood it through a simulation, can we test our understanding now?
Yes, yes, we can understand it also.
We have self-evaluation segment here.
We have self-evaluation segment here. It is,
and it doesn't mean that you don't require a teacher. You definitely need a teacher, but when you test your understanding, you still have problems. You can always go back to the theory or NCERT textbooks or your teacher.
Yes. So see, after completion of this simulation, again in the same TOC, this table of content, under learning resources, you will see this assessment, household circuits assessment. So you click on it, this assessment part. So once you click it, it loads your content, and here the questions based on this household circuits are available. And you can do these questions one by one. Student can go through this question one by one, and
are we going to get marks also?
Let's see, some great
Let's
job.
see if there is a scoreboard or not.
Scoreboard or not.
Okay, great.
But it is there. It is there. Scoreboard is there. So total questions are 10. So let's begin.
Sure. And hence it is very important to have a stable internet connection, so that you can access all the features very smoothly. We have this self-evaluation question, but since we do not have enough time left, we will be taking a few of them, and rest you can solve on your own. And in case you encounter any problem, please feel free to get in touch with us. See, it's very important to share your feedback with us, because we have designed this content for you. In case you encounter any problem, in case you want us to modify something, you can write to us on Diksha's email ID, which we have shared in the beginning as well. The best reference material that you have got is your NCERT textbook, because this entire virtual lab has been designed in alignment with your NCERT textbook. So that's the best reference material. Since it's a board class, you are in grade 10, you need to practice the concept again and again in order to understand it better. There are learners who understand through visual medium better than there there are others who understand through text medium better. So we have the visual material for you, which we watched in the beginning, and we have the text as well. And now we are ready with the simulations assessment part.
Yes. So this is the first question, what is the primary safety risk of plugging multiple high power devices like a heater and an iron into a single power strip? So what will happen? Overload will take place. So let's see. The power strip itself run out of power? No, the total current run will overload the single wall socket. So in a single wall socket, what will happen? It will overload it.
Okay.
So let's continue.
So once your answer is correct, it will be highlighted in green. Okay.
Then a short circuit occurs when, let's give a wrong answer
Wrong
to
answer
it.
and see what happens.
Submit. See, it is red is wrong, correct is the live wire comes into direct contact with the neutral wire, then only short circuit takes place.
Okay.
Because one is high voltage and another is low voltage, and whenever they are interconnected, obviously short circuit will takes place. So basically we gives the current entirely passes through our home and goes back through the neutral wire, and it's like how many units we have used, how much energy we have consumed. That is observed in a kilowatt hour.
Right.
What is the main purpose of green earth wire? To provide a safe path for a fault current to ground, preventing electric shock. Right. So in this way, the 10 questions are there. We can continue with the rest of the questions. Yes.
And ma'am, in case we have attempted all the questions, but we are not satisfied with the answers, we need to learn things again. We can always go back to the theory part from our textbook.
Yes, theory textbook also. Here again we can go to the theory of this from the resource itself, and in the NCERT, because it is a in NCERT class 10th topic, and the very detailed way they have written the entire theory, so they can go through there and read it exactly.
Ma'am, you mentioned in the beginning that these virtual labs are just an add-on. They are not replacement of real physical laboratories, and neither are the teachers. Very briefly, I want a message from you for all the teachers out there, how they can integrate virtual labs in their routine teaching learning, especially for a subject like physics.
Yes, they can plan this virtual lab in their lesson plan itself, and suppose they are teaching this household circuit itself. Once they have completed the theory of from the NCERT, they have explained the entire key points related to this household circuit and its importance. They can definitely give this assignment as a activity to the students, so they can
practice at home
and then get more immersive experience of this topic.
That's right. And now we have to wrap up this topic. Here we learnt about demonstration of simulation on household circuits. For this entire journey, let me thank my expert for her valuable contribution and for explaining the topic with the help of virtual labs. Ma'am, thank you so much.
Thank you.
And I must also thank my ISL interpreter, Ms. Anushka Sharma, along with my entire team for making this session a success. Thank you. Tomorrow we will come up with yet another topic of virtual labs for you. So please make sure you stay tuned in and give your feedback. And apart from virtual labs, what all we have planned for you through the day, here is the program schedule for the same. So in a short while from now at 11 o'clock, you will be watching our session of Ijadi Pitara. 12 p.m. we will bring you a session of our inclusive classrooms with the subject Hindi, and then from 2 p.m. to 5:30 p.m. back to back, we will be having sessions for class 3 and class 4, including our online training program and the session Sahyog. With this, it's a wrap. This is me, Harpreet Kaur, signing off, and we'll join you shortly. Namaskar.